Hello everyone, welcome back to my channel. Today we are diving into the discussion of Karl Popper's philosophy of science, which is a part of the study of approaches to scientific knowledge and investigation. In this video, we will explore the revolutionary ideas of Karl Popper, the philosopher who challenged how we define real science. Actually, Karl Popper's philosophy of science is not about proving theories right, it's about trying to prove them wrong. But how? Let's break it down. First of all, we see the basic idea of Karl Popper's philosophy of science. Popper challenged the positivist philosophy of science by rejecting inductivism and proposed an alternative approach which is called hypothetico-deductive model. Before Popper, positivists believed in inductivism, the idea that observations alone could lead to universal truths. For example, every swan I have seen is white, so all swans must be white. Sounds logical, right? But Popper said no. One black swan destroys the theory. Popper argued that no amount of confirmation guarantees truth. Instead, he flipped the script with falsibility, which is the key criterion for scientific theories according to Popper. That means a theory or statement is scientific if and only if it can be disproven. Thus, Karl Popper's philosophy of science is fundamentally different from positivist inductive reasoning. Now we see the fundamental difference between inductivism and hypothetical deductive model. In case of theory dependence of observations, inductivism suggests that observations are independent of theory and form the foundation for generalizations. But Popper argued that observations are theory laden and serve to test theories, not to derive them. In case of rule of testing, inductivism suggests tests confirm the truth of a theory. But Popper argued that tests aim for falsification, not proof. Theories remain tentative until refuted. In comparison between verification versus falsification, inductivism seeks confirmation of theories, which is verification. But Popperian philosophy actively seeks refutation that depicts falsification is the key to science. The analogy of inductivism versus hypothetical deductive model is inductivism assumes innocence until proven guilty, but Popperian philosophy assumes guilt until proven innocent. Before digging into the comparison of positivist philosophy versus Popperian philosophy, we see how Popper's scientific method works. First of all, it identifies a problem, then it formulates a hypothesis. After that, it deduces implications and attempts falsification. Finally, if not falsified, the hypothesis is corroborated but remains provisional. Up next, we see the advantages of the hypothetical deductive model, why it is better than inductivism. Three reasons: encouraging critical thinking, facilitating scientific progress, solving Hume's problem of induction. Hypothetical deductive model emphasizes falsification over confirmation and keeps theories open to refutation, fostering intellectual rigor. It actually prefers critical thinking over comfort. This model facilitates scientific progress as inductivism leads to narrowing theories, but Popper's approach leads to broader, improved theories. This depicts progress through pain. Finally, the model solves Hume's problem of induction. David Hume argued that you can't prove that the sun will rise tomorrow. Popper also agreed on that. One falsification is decisive, while no amount of confirmation can prove a theory. Science is not about certainty, it's about survival of the fittest theory, according to this model. Now we see the scientific progress in Popper's philosophy in comparison to positivist philosophy. Popper's philosophy indicates progress through theory transition. Science moves from one theory to another with greater explanatory power. For example, Newton's gravity ruled for centuries until Einstein's relativity replaced it by explaining Mercury's wonky orbit. That's verisimilitude. which means closeness to truth. Theories get closer to truth but never arrive. Popper's philosophy represents nature of scientific growth. Popper saw science as a relay race. Old theories pass the baton to new ones, but only if they are stronger. No sacred truths, just endless upgrades. Thus, science advances through continuity and convergence. Finally, the difference between positivist philosophy and Popper's philosophy is that positivist thought science progresses cumulatively, while Popper argued that science progresses through replacement and refinement. Now, Popper's take on objectivity in science. Positivists thought science was objective because it relies on pure theory free observations. But Popper argued that objectivity comes from intersubjective testability. Science is public and open to scrutiny. He depicted the interplay of observation and theory. Observation is not independent of theory. Popper humorously addressed the debate about whether theory or observation comes first with earlier observation or earlier theory by comparing it to the chicken and egg problem, which asks, is it the chicken or the egg first? Here, chicken reflects theory and egg reflects observation. Popper asserted that both are interdependent, so we can't separate them, and it's a continuous cycle. For Popper, objectivity is not about neutrality, it's about making your ideas vulnerable. So, publish, debate, and let the community try to tear them apart. That's how science self corrects. Here are the key tenets of Popper's philosophy of science. They are scientism, methodologism, methodological monism, hypothetical deductivism, falsifiability, interdependence, value judgment, realism, verisimilitude, and rationality. Karl Popper taught us that science thrives for criticism. So now let's practice what he preached. We are dissecting the biggest critics of his philosophy. Is falsification flawless? Does science really get closer to truth? Let's find out. Popper argued that new theories replace old ones but keep their limiting cases. For example, Newton's laws still work for everyday speeds. Einstein's relativity just expands the picture. But critics say, not so fast. Theories like phlogiston or Ptolemy's earth centered cosmos did not merge into modern science, they were scrapped entirely. Here comes Thomas Kuhn. He argued that science is not a steady climb, it's a roller coaster of paradigm shifts. Think about Copernicus versus Ptolemy. Their worldviews were incommensurable. We can't compare them like iPhone updates. Speaking of verisimilitude, Popper's idea is that science inches closer to truth. Critics pounce, how do you measure closeness? Is quantum mechanics closer to truth than Newton's laws, or just different? Popper never gave a clear formula. Without a way to quantify closeness to truth, verisimilitude feels like a philosophy flex. Finally, in summary of Karl Popper's philosophy of science, we find the following aspects that are falsibility as the criterion of science, hypothetical deductive method, scientific progress, critique of induction, and objective science. Popper said objectivity comes from public scrutiny, not pure observations. But if all observations are theory laden, is science just a never ending debate club? Critics argue that without neutral facts, science risks becoming a popularity contest. What's Popper's reply on that? That's the point. The more we argue, the closer we get, maybe. So, was Popper wrong? The answer is yes and no at the same time. His ideas are not bulletproof. but they are brilliantly provocative. Science is not a straight line, it's messy, glorious brawl, and that's why we love it. That's all for today. Drop your take on the comment section. Do you think falsification is still the golden rule of science? Or has Popper's philosophy been falsified? Also, you can share your views on Popper's philosophy of science on the comment section. Thank you for watching this video. Smash like, subscribe, and stay skeptical.